Okay, so this is the first segment of notes on solutions. We've got some definitions here, and very, very important that you keep track of what is your solute and what is your solvent. Now, we did this first part in class the other day, composition, and we've got lots of different ways to do composition, molarity, which we've done before, and note moles of solute over liters of solution, mass percent, mass of solute over mass of solution, mole fraction. I wrote it as moles of A, but it's moles of solute over total moles of solution. So moles of the solute plus moles of the solvent. Molarity, moles of solute over kilograms of solution. That is a very, very important typo. That is kilograms of solvent. Need to make sure everybody's got that fixed. Sorry about that. Then normality equivalence over liters of solution. We're going to use that with acids, usually. And so we did this problem, and it asks you for a lot of different things. Density, mole fraction, molarity, molality. It didn't ask us for percent, but we could do that as well. So we need to keep track of things. We need to keep track of what is the solute and what is the solvent. So the solute is this, and the solvent is water. We make ourselves a little chart. Keep track of everything we know. So we know the grams. We have 10 of this, and we have 100 of water. We know that there's 100 grams of water because there's 100 grams per milliliter for water. And so we know that the whole solution will have a mass of 110. Okay. Molar mass. Well, we know that there's 18.02 molar mass for water because we've done that so many times before. The molar mass of H3PO4, 3.03 for the 3 hydrogens, plus 30.97 for phosphorus, plus 64 for the 4 oxygens, so we have 98. So our moles divided by 98, we have 0.1020. We keep some extra digits. And then 100 divided by 18.02, we have 5.549. So 5.549 plus 0.102, so we've got 5.651 for our moles. So, is that all we need in this to keep track of everything? Well, let's go through these. Density. Density is mass divided by volume, and we want the density of the solution. So we have the mass of the solution, 110 grams. The volume of our solution was given as 104 milliliters. I didn't put that in the chart because other than density, we don't really use it. So we don't necessarily need it for the other substances. But maybe we do need it in the chart. We'll see. All right, so 1.06. And then we need mole fraction. So mole fraction is going to be the moles of solute over the total moles. Well, we have the moles of solute, and we have the total moles, and I copied it wrong. Okay, we're just going to erase it and start over since apparently I didn't switch back to marker. So 0.08180. 3 significant digits. Mole fraction is not going to have any units. Next, we need molarity. Molarity is moles of solute over liters of solution. So you know what? Let's put volume in our chart because we've needed that we have 104 milliliters of our solution more than once, except and we would have 100 milliliters of water. We don't actually need that, but to keep our chart. Okay, so our moles of solute is the 0.102. Liters of solution would be 0.104 liters. And you can see that this is going to come out to be pretty close to 1 since we have 0.102 divided by 0.104. So we get 0.981. So now we need our little m, our molality, moles of solute over kilograms of solvent. Sorry for that earlier typo. So we have that 0.1020 moles divided by, we know we have 100 grams of solvent, so that means we have 0.1 kilograms. Don't need a calculator to do this. 0.102 molal. Now you know what? Problem didn't ask us to do it, but let's do our percent by mass. So that would be grams of our solute over grams of our solution times 100. So we have 10 grams of solute, 110 grams of solution. So we have 10 divided by 110 times 100. So we have 9.09%. And that is everything that we can do solution-wise. We could do normality as well. Let's go ahead and add normality to this. Normality is equivalence per liter of solution. Well, we have H3PO4. So we have 3H plus and PO4 3 minus. So we have 3 equivalents per mole. So our normality would be 3 equivalents over liters of solution. So our liters of solution is 0.104 liters. So 28.8. And this one is not as often used as our other ones. And you can see those first ones that we did, putting the information in the chart. And remember how we did that chart first before we ever even figured out what we needed, because we got everything organized.